Thank you guys for coming. This is a fantastic event. I was actually approached by Dean quite a while ago, and I came to one of the first events for the Amputee Long Drive Championships. That was in Tennessee, and that was a life-changing moment, and that really motivated me even more to continue what I was already doing. Sorry.
I can't hear it yet. Keep it up as close as you can.
So when I was little, I used to take apart everything I got. I used to rip apart toys, microwaves, everything, just to try to understand how things work and why things worked. And I was just so motivated and trying to figure everything out. When I was 14, all that tinkering kind of turned into something practical. My first idea was to create this robotic hand controlled by a glove. So essentially you would put on the glove, when you move your hand, the robotic hand will mimic your movements. It was a telerobotic hand. Now that alone has tons of applications, not only for space, any dangerous environment. What I was thinking is mainly the military for bomb defusal. Instead of having a soldier learn a new claw system, they put on this glove and it would be as if they're actually out there. Now this is just for fun for me. I started working in my bedroom, and I was 14, I didn't have a lot of materials laying around. I used Legos as supports, a lot of electrical tape and electrical tubing as the fingers. And then I had to hand sew the sensors onto the glove. And, it worked, and that was fantastic. I was 14, and, I was just making something for fun, and it worked. And it was amazing. And so from there, I wanted to keep building something. I wanted to keep making this better and better. And so I started designing everything in the computer. And so I designed this whole robotic hand in a CAD software. And I needed to turn all those files into a physical object. Now, at the time, there's this really cool evolving technology called 3D printing. It's amazing. There's no limits to it. The only limits is really size and material. And that alone, I mean, it's an amazing machine. Whatever you design in the computer, it physically makes in front of you within a matter of hours. And just that thought alone is mind-boggling. It's amazing. And it's starting to revolutionize the whole medical field, and already starting to revolutionize the prosthetic industry as well. Now, I ended up making the full robotic arm, fingertip to the shoulder, and I didn't have a whole lot of money to put into this. I had about $500 from working over the summer to put into this project, and so I needed to find a way to make a full robotic arm that's capable of lifting itself up, as well as lifting more extra weight with itself, but also looks really cool, and it actually functions. And so I needed some way to make all that for $500. Now, I could buy really expensive motors and really expensive electronics to make all this happen and piece it together like that. But again, I didn't have that kind of money, and so I had to find compromises between strength and cost. For example, with the shoulder motor, that's a tremendous amount of torque to even lift itself up. 2 pounds in the hand can be 20 pounds into the shoulder, and so you have a lot of torque going on. And so what I ended up using was a really beefy geared DC motor. Now, DC motors generally want to spin in one direction for as fast as they can for as long as they can. Now, I needed some way to limit that. And at the end, I was really only using about 0 to 90 degrees of the rotation of the final end shaft of the motor. Now, I needed some way to limit that. And so I made a quick fix, and I ended up using a potentiometer, which is a variable resistor. It's what's found in light dimmers. And I slapped on the end of the shaft, and I was able to control the motor accurately to about 1/10 of a degree, and control speed, direction, everything with the system. And so that's what really kind of kickstarted this project, is just kind of finding different innovations along the way to make things more affordable, but also really functional. And that's in the end, that's what really made it, stood out from everybody else. I took this arm to the science fair, and this moment happened there. I met this 7-year-old girl that was there. She came up to me, she was playing with the arm, and I didn't really think anything of it. And then I noticed that she had a prosthetic limb. And I started talking to her parents more about it, and I found out that just that alone was $80,000. Now her prosthetic limb, it wasn't anything fancy. It was from the elbow to the fingertip, one motion, open, close, and one sensor. Now that alone was $80,000, and that was really the aha moment for me, that I could take what I was doing for fun, transfer it to prosthetics, and potentially change people's lives. And that's what really kept me going. Something I made in my bedroom for fun could change people's lives, and that was just an amazing thought, an amazing moment for me. And from there, this is the product of this. I instantly found that there was a lot of problems with the current prosthetics. They're heavy, they're bulky, they're hard to use, they're not very functional, open, close. I challenge you to use your hand, a single hand, just for a day with one motion, and to see how much you actually take it for granted, and how respectable the human body is in that sense. So I dove into this, and I wanted to fix all these problems. I needed to make an arm that weighed less than a human arm. The human arm weighs right about 9 to 10 pounds. This arm is currently 9 pounds. And I needed to make it extremely functional, if not more functional than a human arm. And so I needed to add the same degrees of freedom, almost the same strength, the same functionality, all within the same system. Also, I needed to create a whole self-contained system. I didn't want, the users to carry backpacks of different batteries, different processing power. I want everything self-contained. And that was a trick, trying to get, this much power, this much strength, this much functionality in such a small package. But this is what really 3D printing allowed me to utilize, is that I was able to print custom gearboxes within it, print custom fingertips, everything. This is all 3D printed. And because of this, I was able to reduce the cost tremendously. This arm is actually controlled using your brain. There's a wireless brainwave headset that you actually wear. It's completely external, and that was a big approach going into prosthetics, is that it has to be psychologically easy on the user. And so it's completely external. They can take it off whenever they want. You can easily conceal it within a baseball cap, and it's solid. It works. And so I was able to build this full system, fingertip to the shoulder, with a whole brainwave control system for about $400. Now, most smartphones out there cost more than that, so there is no reason that, a prosthetic should cost $80,000 with one motion. Again, they're in it for business. There's really no competition out there for prosthetics so much. They can put a price tag on it. I could put a price tag for $1 million on this, and people would still buy it just because it's so crucial. It's such a big part of life. But you're going in the wrong direction if you're not helping people in that sense. You give them a tool, but for the rest of their life, they're always worried and stressed about how they're actually going to pay for this tool, and that shouldn't be the case. Already I'm working on a third generation. Third generation is going to top everything so far with this. It's lighter, weighs right about 6.5 pounds, stronger. The math says it can lift right about 150 pounds straight out like this. And the cool thing is it's extremely efficient. I can turn the whole motor off, I can turn the whole arm off, and it will actually hold 150 pounds straight out like this. Now it's extremely efficient. The whole arm takes 6 volts to power the whole system. I actually developed this new actuation system, which is, number one, extremely lightweight, strong, and efficient. And this is really the key. Now, I'm not stopping at the prosthetic limb. I'm actually creating this whole exoskeleton suit with this new actuator system. And the inspiration behind that was, there was this young man I go to school with. He was in a car accident. He was paralyzed from the waist down, 2% chance to walk again. And my goal is to have him walk at graduation. So, essentially, it's a suit that's completely external, and will stand for him, will walk for him, will balance for him, will detect stairs. And this is the future. It's not only going to help him, but thousands of other people out there. And with the system, it will give you life you've never had before. It will give you strength you've never had before. And I believe this is the future. And so throughout this whole process, curiosity has really kept me going. It kept me asking questions, trying to understand why things work, how things work the way they did. And so I challenge you to be curious and to challenge the system and to redefine the boundaries that systems create. Thank you.